Hey, Matt 143. Today we are starting on chapter 7, and so we wanted to start talking about probabilities. And so I wanted to take a look at a pretty easy problem. It's a problem I think might be even covered in an example in your book or something like it. But I wanted to show you a different way of looking at the problem that I thought you might find helpful. At any rate, so let's see what the problem is. The problem is Lipkin's got papers going everywhere. Okay, the problem is, what's the likelihood you want to cast 3 heads? You got 3 coins. You're going to cast all 3 coins, and you're going to get heads on all 3 coins. Okay, and so the first thing is you have to determine the probability of a single event. Do you think the likelihood of getting heads is 50-50 on a coin, a typical coin? Well, of course, head side weighs more. I don't think we're really going to worry about the slight weight difference in the coin. At any rate, we will assume the probability of a single event is 1/2 or 50-50. It's a coin flip, right? Well, what's the probability of the 3 events happening all at once? And that's where you just go 1/2 to the 3 power, and then you'll get 1/8, right? And that's what your book explains to you. That's the college math way of doing it. That's for sure. Okay, you want to be able to do that. It's really quite easy doing that. But what I wanted to do is give a second look, and this one I think it might help you to understand this problem a little bit. Okay, so here's my second look. Oh, shoot, I meant girl and boy. I just meant heads and tails, all right? Oops, I messed that up. Let's go with heads and tails. I was thinking of a different problem. All right. At any rate, and now I'm going to make a list of what could happen. I could roll tails, tails, tails. I could roll tails, tails, heads. I could roll tails, heads, heads. I could roll heads, tails, tails, heads, heads, tails. And then last but not least, after I get through all these different events, I come to the one, oh, look, I could roll heads, head, head. Right? And everything is good. Okay. Okay, and now here, of course, and I got flustered because my X's and Y's, but I think you understand what I'm talking about here, which is, of course, I've made a list of all the events that could happen. There's one event out of that list that actually satisfies the question or the conditions I wanted. There were 8 different categories in that list, and so the probability would be 1 in 8 there, right? Okay, and that's all well and good, but there's one other little kind of thing that threw me off personally the first time I got to it, and this is a question that, heck, I thought it was the same question, which is, what are the odds on getting 3 heads and 3 coins tossed? Okay, and I thought, when I first heard this question or saw it, I was like, well, heck, that's the same question. It's just 1 in 8, of course, but it's not. You have to look up the definition of odds, and so it comes way back to the original thing. Read the question and understand the difference. And in this chapter, I think it was chapters 7.1 and 7.2, but 7.1 or 7.2 talked about odds, and 7.2 talked about probability. They don't mean the same thing. They sound like they should, but they don't. At any rate, so you have to look up how odds are defined. Okay, and so here we go. Let's look up how odds are defined. The odds of an event are the probability the event will happen against the probability the event will not happen. Okay, you can look that up in your book, of course, but here we go. The odds are, therefore, there was 1 in 8 chances that we get all heads. There was 7 in 8 chances that we wouldn't get all heads, right? Now, the odds against this is 1 in 7. Okay, and now, of course, let's step back and think about what that means. And we're adults, and we can think about gambling games and gambling houses, and that means that if you put up $1, you should win $7 if you toss all three coins and make um, a heads, right? Now, in real life, if you go to a casino, and so for instance you had a 1 in 8 chance of something happening in a casino, and in the casino, are they going to give you that 7-to-1 odds that you should be deserve on such an event? And the answer is, of course, no. It's kind of interesting, but you can look up the different casinos have to publish their take, and so therefore you can look up the different casinos, what their take is, and you will notice that for instance Cherokee, North Carolina, I think has a take around 8%, whereas Las Vegas has a take around 7%, at least on the one-armed bandits, the slot machines. At any rate, you can look this up online, so don't trust my figures by any stretch of the imagination. But by doing that, you can actually use your math to know where you should go play the slot set. The first thing is, of course, you shouldn't go play them because you're going to lose. I just said the odds are stacked against you. How do you think Las Vegas pays for all those fancy lights? But at any rate, life is short. You got to make the most of it. Maybe you want to go out there. At any rate, but the college person might want to look up the odds of these different places to figure out where they want to travel to. Do you want to travel to Las Vegas, or do you want to go to Atlantic City? At any rate, I hope you enjoyed the take on it. I thought the event list is a good way of visualizing the problem in a different way, and although you don't really want to work the problem that way, I think it's good to work through it that way at least once, because that way you can kind of see what this all means. At any rate, good luck to you. We'll see you soon.